So this question says, find all solutions to the equation sine of 2x equals 1/2. So when we look at the unit circle, there are certain angles that would give us a sine of 1/2. One of these angles would be 30 degrees. For a 30-degree angle, the height of the arrowhead off the x-axis would be 1/2. But also, a 150-degree angle, that could give us a sine of 1/2 as well. Now, when we go to calculator to do the sine inverse of something, it's only going to give us one answer, the 30-degree angle. That's because sine inverse is only has a range of certain angles. So the range of arc sine or sine inverse of theta is from negative 90 degrees to 90 degrees. So that is from here to here. So even though the sine of 150 is 1/2, when we do sine inverse of 1/2, it just gives us the one answer, 30 degrees. That's because a function can't output more than one value. A function can only output one value for every input. So if you input 1/2 into sine inverse, it can't give you both 30 degrees and 150 degrees and potentially other angles as well. It's just going to give you the 30 degrees. So we have to have a way of stating the solutions to this going beyond just what the calculator gives us. So if we try to solve sine of 2x equals 1/2, let's see what we get. I would take a sine inverse of both sides to solve it. Sine inverse and sine would cancel out, and we'd get that 2x is the arc sine of 1/2, and then x is going to be arc sine of 1/2 over 2. If we plug this into calculator, we are going to get one answer, which is 15 degrees. But that is not the only solution to the equation, because there could be potentially many other things that we could plug in for x here and get 1/2. So what would that other angle be? Well, let's see. So 15 degrees would look like this, approximately. So if x was 15 degrees, that would work, because we'd be doing the sine of 30. So now I have to see what else could work. We know that we have solutions. Solutions occur where 2x is 30 or where 2x is 150. So where does this leave us? That would be when x is 15 degrees or x is 75 degrees. I'm going to draw both of those solutions here. But it's possible that there could be even more solutions. So we might think about what other angles could satisfy these conditions. So our solutions could really be described as x equals 30 degrees over 2 and also 150 degrees over 2. But there are more possible answers as well. If I start here on the right at 0 and go all the way around the circle, that would be 360 degrees. Now if I keep going to the red arrow here, then I have traveled 360 plus 30 degrees. And I'm now at an angle of 390 degrees. And the reason why I'm bringing that up is because the sine of 390 degrees would also be 1/2. So my point is that even though 2x equals 30 is a possibility for a solution and 2x equals 150 is a possibility for a solution, also, if that 2x were to be 390, that would be a solution as well. We can try it. Try the sine of 390 on calculator. It's 1/2. And there's another possibility too. If we keep going from there and go to this arrowhead, we would now be at an angle of 360 plus 150, which would be 510 degrees. So if 2x were to be equal to 510 degrees, that would also be a solution. This process could keep going. So the way we write that is that we could say that 2x needs to be 30 degrees plus 360 times n, where n is any integer. So if n was 0, then we'd be at 30 degrees. If n was 1, we'd be at 390 degrees. If n is 2, we would be at 720 plus 30, which is 750 degrees. And the sine of 750 is also 0.5. Now let's write the other one. The other possibility is we could be at 150 degrees plus 360n. Alright, so this is just a clever way of writing all the possibilities that would satisfy this equation. Now we can solve by dividing by 2, and we can get x alone. And we'll do it for both of those possibilities. And these are our solutions to the equation where n is any integer.